Uh, so which of the question number 158? 158. Which of the following substances are likely to behave like Lewis acids? AlBr3. This we have seen yesterday, it seems. AlBr3, I told you it is aluminum is having a sextet, Br, Br, and Br. Aluminum is having 6 electrons, so it can accept 2 more electrons. Already having only 6, it can accept 2 more electrons, so it can act as a acceptor of electron, that is acid. So it is a Lewis acid. Then CH3, CH2, NH2. CH2, NH2. Remember, it is having a pair of electrons here. So it can donate these electrons. That means it's a Lewis base. So Lewis acid accept electron. Lewis base donate electron. Next one, HF. HF. HF is highly electronegative. See here, this bond is very polar. So the hydrogen is lacking electron. So the hydrogen can accept electron. So this will act as a Lewis acid. CH3, CH3, S, CH3, dimethyl sulfide. See here, it's got 2 lone pair of electrons. So it can act as a Lewis base. Okay, now 1.59. Ammonium ion, NH4 plus, pKa value of 9.25. NH4 plus has a pKa value 9.25. Now, do you know what is pKa value? You can simply think pKa value means, so this is NH4 plus. Now, the pH at which this proton can be taken by a base is known as pKa value. The pH at which this proton will be taken up by a base is what is known as pKa value. Okay, so if you put ammonia, if you take ammonium chloride, NH4Cl, if you take ammonium chloride solution, then into this you add sodium hydroxide solution, slowly. Add NaOH very, very slowly. A dilute solution. Okay. Ammonium chloride is slightly acidic in nature. It is slightly acidic. When the pH comes to 9.25, when the pH reaches, you are keeping on adding sodium hydroxide means you are increasing the pH. The moment the pH comes to 9.25, the sodium hydroxide will start taking away this proton. By this movement, what will happen? Ammonia will be coming out. Right? So only above the pH 9.5, the ammonia gas will come out. Or in other words, NH4Cl plus NaOH will give NaCl plus H2O plus NH3. At what pH this reaction will start? At 9.25 pH. That is the meaning of this. What is a pKa? So pKa is the pH at which a particular proton can be removed from the system. Right? Okay, now, so ammonium is having a pKa value of 9.25, has a lower pKa than methyl ammonium ion. Is having a lower pKa than methyl ammonium ion. Which is the stronger base, ammonia or methylamine? Which is the stronger base? Now let us look at methylamine and ammonia. See here. This is the difference between methylamine and ammonia. From ammonia, you remove one hydrogen and put a CH3. Now, without looking at the pKa value and all, without looking at the pKa value, just look at this structure. Which will act as a stronger base? Which will act as a strong base? Which base is stronger? Methylamine is stronger base because by inductive effect, the electrons are donated towards the nitrogen. So the electron density on the nitrogen increases. Electron density increases means it's a stronger base. Now connect this. So this is a stronger base. So we'll put this as strength of base stronger. Now let us look at the pKa value. See, as the pKa value increases, pKa value is 10.66. pKa value increases, basicity increases, acidity decreases. Okay, when pKa value increases, basicity increases, acidity decreases. So you can see here 10.66 methyl ammonium ion is more basic. Next one, is the bicarbonate ion a strong enough base to react with methanol? In other words, does the following reaction take place as written? Yeah, what is the reaction? CH3OH plus HCO3 minus. Give CH3O minus plus H2CO3. H2CO3. Okay. Now, pKa value of methanol is 15.5. 15.5. And then what? pKa value of H2CO3 is 6.4. 6.4. Now see here. You are decreasing the pKa value. Okay. So 15.5 is the pKa value of this one. And this is 6.4. So you are decreasing the pKa value from 15 point. Now it is impossible. It is impossible. Okay, that is the pK value should increase. That means if this is 15.5, this the acid which is generated, should have a higher pK value. Okay, so this reaction will not work. And also you can think of this. See here, this is a very weak base, a weak acid. It's a very weak acid. And this is a strong base, very strong base. And this is a weak base. Now, a weak base cannot generate a strong, a weak base cannot generate a strong base. A strong base can generate a weak base. Okay, so that is the simple logic. And compared to, see this is an acid. pK is 15.5. Here is an acid which is stronger. A weak acid cannot prepare a strong acid. Is it clear? So this is how you consider the Harsha mute. Harsha mute. You have to mute your. One second. Let me mute. Yeah. Okay. Right now. So that is next one. 1.61. 1.61. Ammonia has a pK of 36. Acetone has a pK of 19. Will the following reaction take place? Let's say, look at it again. Acetone, CH3, CO, CH3 plus NaNH2 minus. Giving ammonia plus CH3, C11, CH2 minus. Now let's look at the pK values. Ammonia 36. Ammonia 36. And acetone 19. Acetone 19. Okay, now see here. What acetone is doing is giving proton. Acetone is giving out a proton, right? And it is forming a conjugate base. So this acting as an acid. Acid pK value is 19. And what is the acid here? Ammonia is an acid here. Okay. It is having a pK value of 36. So I told you just now, pK has to increase. Here you can see the pK has increased. The pK of the acid on this side is 19. pK of the acid on the other side is 36. Okay. So this is the acid on this side. See, this is the base. This is a conjugate acid. Conjugate acid. This is the acid. This is a conjugate base. Okay. So the pK of the acid is changing from 19 to 36. That means the reaction is favorable. this reaction will occur. Okay, so this is what you have to look into. It is the other way here. In the previous example, the pKa has decreased. That will not occur. Okay, so this reaction will occur. Next one, identify the acids and base in the following reactions. CH3OH, CH3OH plus H plus. Remember, these are simple problems, but it will give you a clear concept of basics. CH3OH2 plus. CH3OH2 plus. Now, which is the acid, which is the base? Yeah. What is happening? Look at the, just simply write the mechanism. There is a lone pair of electron on the oxygen. This. And it forms this product. So this will be acting as a base, and this is acid. A proton acceptor. Second one, CH3OH plus NH2 minus. CH3OH plus NH2 minus. Giving CH3O minus and NH3. But again, the same thing. NH2 minus is having a lone pair of electron. So this NH lone pair is accepting this proton and keeping this off. So this is acid, this is base. Okay, next one, acetaldehyde, CH3, CHO. Reacting with ZnCl2. Reacting with ZnCl2. Okay. Now zinc, Cl and Cl. Zinc is electropositive. Okay. Now this lone pair of electrons, always think about lone pair of electrons. If you have a compound with lone pair of electrons, generally it will act as a base. So it will form a C-double-bond O. It will form a weak bond here. Zn, Cl, Cl. What is the message? Let me see, somebody else. Oh, sorry. Once the message condu, is it to me 1.56 to 1.62 questions?
Sir, our questions
Yeah. 1.60. Okay, കുഴപ്പമില്ല. Okay. Yes. Okay. അങ്ങനെ വേണമെങ്കിൽ നിങ്ങൾ ഒന്ന് അൺമ്യൂട്ട് ചെയ്തിട്ട് പറഞ്ഞാൽ മതി കേട്ടോ, മറക്കണ്ട. ഞാൻ ഇത് നോക്കാൻ മറന്നു. ഇറ്റ്സ് ഓക്കെ. ഓ, ഇത് ഞാൻ അയച്ചു തന്നിട്ടില്ല അല്ലേ? ഓക്കെ. Oh, now 1.63. 1.63. Predict അത് തന്നിട്ടുണ്ടല്ലോ അല്ലേ? Right. Predict the structure of the product formed in the reaction of the organic base pyridine with the organic acid, acetic acid. Okay. I'll clear the board first. Let me remove all this stuff. Sorry, is one second. Okay. Now, yeah, pyridine plus acetic acid. This is pyridine. Plus acetic acid, CH3 COOH. Now remember, pyridine is having a lone pair of electrons here. And it can accept the, now this is an acid. And acid means the OH bond is, the H on the OH bond can be taken by a base. So the product is going to be, this is going to be the product. And H with a positive on the nitrogen and CH3COO minus. So this is pyridinium acetate. So that is a product. And this is the direction of the electron flow. Okay, now we will, next one. What do you suppose no one has ever been? Yeah. What do you suppose? Why do you suppose no one has ever been able to make cyclopentane as a stable molecule? Okay, you must be knowing the reason, right? A simple, interesting. Yeah, I hope now some of you can. Anybody can tell me the answer? ആരെങ്കിലും അറിയുന്നത് അൺമ്യൂട്ട് ചെയ്ത് പറഞ്ഞേ, പറയൂ. എനിബഡി ആരെങ്കിലും അൺമ്യൂട്ട് ചെയ്ത് പറയൂ. Why do you suppose no one has ever been able to make cyclopentane as a stable molecule? പറയൂ. ആരെങ്കിലും പറയൂ. Come on. നിങ്ങൾ 13 പേരുണ്ട്.
It has a triple bond in the molecule.
ട്രിപ്പിൾ ബോണ്ട്.
ഉണ്ട്.
അപ്പൊ അതുകൊണ്ട്
ലീനിയർ ആയിരിക്കും വരിക.
Exactly. Triple bond is having a bond angle of 180, which is not possible here. That's correct. It is having a triple bond, but the expected bond 180 is not achieved. So there is a lot of ring strain. Next one. Draw the orbital picture of allene. Oh, beautiful question. Look here. CH2, double bond, CH, double bond, CH2. What hybridization must the central carbon atom have to form two double bonds? What shape does allene have? Anyone of you have drawn this? Anybody? Now do see here. I'll just wipe out the board and tell you. It's a very good question. See here. CH2. Look here. Look at this picture. Now let us come to the first carbon. See this. I have drawn this carbon in this way. I can draw this carbon in this way also. See here. Look at these two pictures. Now here, the sigma bonds are in a perpendicular plane to the board. ഇങ്ങനെയാണ് ഞാൻ സിഗ്മ ബോണ്ട് ഇവിടെ വരച്ചിട്ടുള്ളത്. ഈ ഒരു ബോർഡിന്റെ പെർപെൻഡിക്കുലർ പ്ലെയിനിൽ. Okay, this may not be something like, let's see, let me see. Okay, suppose I have a C in the center, one H is here, one H is here, and here is a carbon. Okay, now suppose I draw this bond like this, the p orbital on this carbon should be in a perpendicular plane. Can you understand this? The sigma bonds are in the plane of the board here. The sigma bonds are in the plane of the board in the top picture. So the p orbital on this carbon, unhybridized p orbital, should be perpendicular. Suppose the sigma bonds I draw here. Now in this case, the p orbital will look like this. Okay, right. Now there is a double bond here. So the central carbon will also be having a orbital in this direction, so that they will overlap. If I draw the next carbon here, there should be an orbital which will be overlapping here. They are parallel. Then only they can overlap. Okay. Now, the central carbon has got two pi bonds. That means it is sp2 hybridized. Sorry, sp hybridized. It is sp hybridized. sp hybridized carbon will have sigma bond sp hybridized carbon will have a sigma bond and two pi bonds. That means two p orbitals. So one p orbital is already here. Okay, and sigma bond will be linear. Now, in which direction is the next p orbital? In a perpendicular plane here. If I draw it here, it will be in this direction. Okay. Now you have next carbon. This carbon will also have a p orbital in this direction, so that these two can form a bond. Okay. Now if I put the next carbon here, then it will have a p orbital in this direction, so that it can form a bond. So remember, these two p orbitals in the center are mutually perpendicular. These two p orbitals are mutually perpendicular. Then look at the next one. See here, if the p orbital is perpendicular, then sigma bonds have to be in the plane of the board. And if the p orbitals are in the plane, sigma bonds have to be in a perpendicular plane. Okay, now let me draw these two fixtures here without any orbital. See here, C double bond C, C double bond C. The p orbitals, the hydrogens are in a perpendicular plane to this carbon, and in the plane of the carbon here. See this. Okay, if I draw it here, it is just the reverse of it. This is the overall geometry of the molecule. Okay, this we have studied allenes and biphenyls. In stereochemistry. I don't know. I think I have studied it. No. Okay. Anyway, this is the geometry of the molecule. Okay. Right. Next one. Draw an electron dot structure of the orbital picture of carbon dioxide. That is simple. Again, the same thing. Same thing. This carbon is having a sp hybridization. This is sp2. Again, the lone pair of electrons will be mutually perpendicular. These lone pair of electrons here will be in the plane of the bore, and these lone pairs here will be in the perpendicular plane. Just like allene. Okay? Right. Now, although the most stable organic compounds have tetravalent carbon atoms, high energy species with trivalent carbon atoms also exist. Carbocations are one such class of compounds. If the positivities of the carbon atom has planar geometry, what hybridization do you think it has? How many valence electrons does the carbon have? Oh, simple one. You must be knowing what is the geometry of this, right? This is carbon, H positive. So these three are in a single plane, and you have one empty orbital here, which is in a perpendicular plane. So the geometry is going to be triangular planar, right? It is triangular planar. The ammonium ion, NH4 plus, has a geometry identical to that of methane, CH4. What kind of hybridization do you think the nitrogen atom has? Explain. What is hybridization of ammonium? What's hybridization? sp3, N, H, 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 NH4 plus, and CH4. So both are sp3 hydrides. Okay, complete the electron dot structure of caffeine using all lone pair of electrons and identify hybridization. Yeah, electron dot structure. This is the molecule. You have the nitrogen here, C double bond O, C double bond O, and then N here, N here, NCH3. Yeah. So complete the electron dot structure showing all lone pair of electrons and identify hybridization of indicator carbon. Okay. Now lone pair of electrons, two lone pairs here, one lone pair here. Oh, sorry, there is a CH3 here. One second. Still there is a lone pair. There is a CH3 here and a CH3 here. I forgot that. A double bond here and a double bond here. Yeah. Yes. Now, so you have a lone pair here, and lone pair here, and lone pair here, and two lone pairs here on the oxygen. Okay. And hybridization, you know, these are all sp2 hybridized. This is sp2. This also is sp2. This one is also sp2. What else? Yeah, all these three are sp2 hybridized. Okay, the remaining you can do by yourself. The remaining just 2 or 3 problems. Okay, these are very simple problems. Okay, so tomorrow we'll continue with our class, whatever revision we are doing. Continue a little more faster. Okay, right. Okay, thank you.